When we show a diagram of a molecule, we can use different models depending on what we want to show. A space-filling model shows the relative size of the atom's electron clouds. A ball and stick model shows the covalent bond as a stick between the atoms and is useful for showing the shape of the molecule. In this video, we explore another type of model called a Lewis diagram, which shows how the outer or valence electrons are involved in the bonding. Molecules are formed when atoms share electrons to complete their outer electron shells. With the exception of hydrogen, most atoms, like this oxygen atom, are trying to achieve 8 outer electrons. A Lewis diagram shows the bonding and non-bonding pairs of electrons, with the bonding pairs shown as a line to represent a covalent bond. To draw a Lewis diagram for a molecule, like this ammonia molecule, we first consider the number of outer electrons in the atoms involved. Nitrogen in group 15 has 5 outer electrons, and so has this Lewis dot structure. There are 3 empty locations to fill in order to achieve 8 outer electrons, and so it can form 3 bonds. Hydrogen in group 1 has just 1 electron, and since the first shell only holds 2 electrons, hydrogen has just 1 empty location and can form just 1 bond. We start by drawing the Lewis dot structure for the central atom, the atom with the most empty locations, in this case nitrogen. Then we draw the Lewis dot structure for the hydrogen atoms. A hydrogen atom will share its electron with the nitrogen, and in doing so an empty location is filled in both the hydrogen and nitrogen atoms. We draw this shared pair as a line to represent the covalent bond. As each hydrogen shares an electron with the nitrogen atom, the empty locations are filled, giving us this Lewis diagram for an ammonia molecule. Remember that each line represents 2 bonding electrons. So we see nitrogen has a share of 8 electrons, completing its second shell, and the hydrogens each have a share of 2 electrons, completing their first shells. In this next example, we want to draw a Lewis diagram for a carbon dioxide molecule. Carbon is in group 14, so it has 4 outer electrons. And since carbon is in period 2, these electrons are in the second shell. With this shell holding up to 8 electrons, there are 4 empty locations, and so 4 possible bonds. Oxygen is in group 16, so it has 6 outer electrons. And since oxygen is also in period 2, these electrons are also in the second shell. There are 2 empty locations, and so 2 possible bonds. Since carbon has the most empty locations, we start by drawing the Lewis dot structure for carbon as the central atom. And we draw the Lewis dot structure for each oxygen atom on either side of the carbon. An oxygen atom will share an electron with the carbon atom to fill an empty location in both atoms. We draw this shared pair as a line to represent the covalent bond. After each oxygen has shared an electron with the carbon atom, there are still empty locations, as the atoms do not yet have 8 outer electrons. So we share another pair of electrons between the atoms, drawing another line to give a double covalent bond between the carbon and oxygen atoms. After each oxygen atom has formed a double bond with the carbon atom, we see this is the Lewis diagram for a carbon dioxide molecule. Remember that each double line represents 4 bonding electrons. So we see that carbon has 8 electrons and each oxygen has 8 electrons. So, in this video we've seen how we can represent molecules by drawing Lewis diagrams, which show the bonding and non-bonding electron pairs in the molecule, with each pair of bonding electrons shown as a line. We started by drawing the dot structure for the central atom, the one with the most empty locations in its outer electron shell. And then around this we drew the dot structures for the other atoms. By drawing a line to share a pair of electrons, we completed empty locations and formed covalent bonds to give us the Lewis diagram for the molecule.